Okay guys, so today we're going to discuss alternators and how to test and do a voltage drop across an alternator to see whether we have a problem with the alternator or whether we have a bad connection. So I'm going to bring you in and show you a close-up of an alternator. So on our alternator we have our ground and we have our power. Now, if you follow these wires down on this system here, it goes down to a fuse. Now, most systems don't have a fuse, so you're going to follow that back, and it goes down to the power of instead of the battery. Our ground side is going to go to our ground side. So what we're going to need for test equipment is we're going to need a multimeter. We're going to need an amp clamp, and we may need a set of jumpers. So our amp clamp that we're going to be using is a clip-on amp clamp, and if you take a look at the amp clamp, some of them will have an arrow on there to point in the direction of current flow. So for us, what we're looking for when we're doing an alternator is we're taking a look at how much current is flowing out of the alternator as we load it down. So we'd stick this on the positive of the outgoing cable that goes to the alternator. The other thing that we're going to need is we're going to be able to load down the batteries. Number one, let's find out what the output of the alternator is, and we're going to assume that this is a 150 amp alternator. We're going to hook up our battery cables. So we're going to hook positive to positive. And we're going to hook our negative to the negative. Now, the battery voltage reads 12.30 volts. So that's our open circuit voltage of our battery. And that's another thing that we can do with our meter also. So now that we're set up, so a customer comes in and says, I don't think my alternator is charging. So we want to find out whether it's the alternator or whether we have an issue with the wiring. So first thing is we do an open circuit voltage test. So we've got 12.3 volts. It's still good enough that we can check it. So on the load tester, we also have an amp clamp on it. Now the amp clamp on the load tester is going to go on the positive. And again, on here you'll see an arrow. And this arrow points in the direction of flow. And what we're doing is we're not feeding into the battery, we're drawing out through the load tester, so the arrow is going to point away. So we're going to put that on the positive with the arrow pointing away because we're drawing power out of the battery. Now what we want to do, and we're going to do this with the engine running. I'm not going to run the engine because it's too loud, you won't be able to hear me. So we've got the battery hooked up with the load tester on here, engine is running. And what we're going to do now is we're going to load this down to simulate a load on the electrical system. And what that will do is that will tell the alternator to start charging at maximum. Basically, it's going to full field it. So a couple checks we want to do with our meter. First off, we're going to turn our meter on to DC voltage. So we're going to set it up. And what we want to do as we're loading this down, now have everything set up so you can do your load testing all at once. Because we don't want to put too big of a load on that alternator for too long a period of time. So once we are all set up and we got all our cables straightened out, we're going to take and we're going to hook from the positive of our battery to the positive of the alternator. And we're going to read what the voltage is. Now, if you remember from doing a voltage drop, what we wanted to look for is we want to look for 0, or as close to 0 as possible. once we've done our positive, and then we're going to go from our negative of our alternator to the negative of the battery. And that's going to test our whole circuit to see if we have any voltage drops. If that is fine, then what we're going to do is we want to see what our output of our alternator is, and that is what our amp clamp is for. So with the engine running and loading down the battery, the alternator is going to put out maximum amount, and that's going to tell us on our amp clamp. Now the other test that we want to do is we want to do ones called ripple voltage. With ripple voltage, we're going to turn it to AC on our meter, alternating current, and we're going to check from our positive of our alternator to our ground of our alternator. And what we're looking for is we don't want more than 1/2 of a volt of ripple voltage. Now jumper wires, again, because this is pretty compact, it's nice and easy to get at. But if your batteries are behind the cab or further away, you may need a set of jumper wires to hook your meter up. The rest of the stuff we'll use the same. Okay, so as you can see, I've got my positive of my meter set onto the positive stud of the alternator. I have my amp clamp, and I have it around the power wire that comes out of the alternator. And I have my black lead on the ground side of the on the positive side of the battery. And then what I'm going to do is I'm going to read what my meter says. Now the engine has to be running, and I have to be loading down the battery to simulate a load on the alternator. So I've got 0 volts. Now if the engine was running and I have 0 volts, that would indicate that I have no issues with the power side. I don't have a resistance inside there that's creating a voltage drop. Now I'm going to do the same thing with the negative side. So I'm going to disconnect my meter from there, and I'm going to disconnect the meter from the positive. And what I'm going to do is I'm going to do the same onto the ground side. So I'm going to hook my meter on the negative post and up on the negative post of the alternator. Same thing is I'm going to load it down to 150 amps. And what I'm going to be watching for is what does my meter say. So here the meter says that I have 0 volts, which is what we're looking for. So it means that I don't have a bad connection anywhere in the circuit. So once this is done, then again we're going to check ripple voltage. So how do we check ripple voltage? Well, what we're going to do again is we're going to take our meter, we're going to turn it to the AC setting. And then we're going to put our positive lead onto our positive stud. And we're going to put our negative lead onto the ground. And what that's going to do is that is going to read what our AC current is that's coming out of the alternator as ripple voltage. So now we're going to take a look at a starting circuit and how it's set up. So here we have the positive of our battery, negative of our battery, positive of the starter, negative of the starter. We have our S terminal. We have our start relay. Power comes into here. From our key switch it signals here. This is the ground side of the relay, and this is what sends power up to my S terminal. You also notice we have a diode in here. If you remember from when we were talking about circuits, when we collapse a coil, we get current flow in the opposite direction. And that diode's going to help prevent the points or the contact points from arcing. So one of the things when we are testing a starter, we have to make sure that we are cranking the starter over. We don't want to start the engine. But what we want to do again is check voltage drops. So what we're going to do is we're going to hook up from our positive of our battery to the positive of the starter. We're going to have our meter set on DC voltage. We're going to crank it over and we're going to check the resistance between the battery and the starter motor. Now again, what we're looking for is 0 volts. Now once we've done that, Then we're going to check the ground side. And we're going to do the same thing. Now we're going to crank it over again and see what we're getting. Again, we're looking for 0 volts. Anything over 0 volts means we have a problem in the system somewhere. We have some sort of a resistance that is using up some of that voltage. Now, let's just say that we have a problem with the starting circuit itself and it's not working. So again, what we're going to do is if we go from our positive to our positive here, our meter should read 0 volts. Now again, we're going to be cranking when we do this because we want current to flow through this. Okay, so once we've done that, if it's working fine, then no problem. But here is our power input to our relay. So we're going to check that. Now again, we're looking for 0 voltages. Now, let's just say that the start relay, we don't even hear it click. So if I put my meter on here and I crank it over and it shows 0 volts, it means I have a bad ground. So I want to fix that first. Now the other thing I want to do is I want to check across here. Now I can do this as I'm cranking. I can either use this to here and I'm looking for 0 volts, or I can go from my ground to that stud and I'm looking for 12 volts. Because this stud here goes up to my S terminal. So next step is I want to check to see if I've got power up here. Now again, I want to check for a voltage drop. So a voltage drop is going to be from there to here, cranking it over. And what am I looking for? I'm looking for 0 volts on the meter again. Any voltage on there is going to show up as a resistance in the circuit somewhere.